So thank you very much again for presenting.
Yeah, thank you so much for having me as well. And it's never too early to talk about API 6. So today I wanted to talk to you about API 6 in the context of Kubernetes. I understand that a lot of you are Kubernetes experts. You have been using Kubernetes for multiple years. So in today's talk, we'll walk through what an API gateway is, what API 6 actually does, and then we'll move on to Kubernetes and see how you can deploy API 6 in Kubernetes and how you can configure API 6 with Kubernetes native resources. So a little bit about me. I'm a maintainer of Apache API 6. Formerly, I used to maintain some CNCF projects related to service meshes. I try to help new contributors in open source through Google Summer of Code and the Linux Foundation mentorship program. And after this talk, you can find me on Twitter if you have any more questions, and I'll be happy to help you out. So, API gateways. API gateways are essentially a middleman. So, it sits between your client applications and your APIs. So, you have your client applications, your web apps, your uh, mobile apps, and you have your APIs, which could be multiple services, multiple microservices. So an API gateway abstracts out your backend so that your clients have a single entry point and you have a single entry point for all your traffic. So it's basically a software that takes in a user's request and it routes it to one or more backend services. So the primary function of an API gateway is just traffic routing. And once it routes the request to your backend services, it collects the required data and returns it back to the user in a single package. And on top of all this, on top of this routing, it provides other features like analytics, threat protection, security, all sort of stuff, which we'll look into later. And Apache API 6 is uh, an API gateway implementation and implementation of this pattern. So it's a high performance cloud native API gateway and it is hosted by the Apache Software Foundation. And it has features like load balancing, canary releases, circuit breaking, authentication, and some observability features. So you can learn more about API6 at api6.apache.org. Well, right. So let's look at some design patterns with API gateways first so that you get an understanding of what API gateways actually do. So this is an example of setting up authentication with an API gateway. So a user uh, can send a request to the API to the Apache APISIX or any other API gateway, and APISIX will handle authentication. So basically, the user authenticates with APISIX, and once the user is authenticated, APISIX can route the user's request to your backend services. So depending on which user is accessing the service, you can provide uh, tailor-made backend service to that particular user. Similarly, in API gateway, we can do stuff like rate limiting. So if the number of users exceed a certain threshold, or if you want to protect your backend service against a particular like against large traffic, maybe your system won't be able to handle it, or it doesn't have adequate resources to handle such a large traffic. You want to protect your system from getting shut down because of it. So you can do stuff like rate limits. So API6 or any other API gateway will stand between your clients and your backend services and can do this rate limit for you. So if if your traffic exceeds a certain threshold, API6 can choose to reject or delay it so that your backend services are able to handle these traffic requests adequately. It can also do stuff like canary releases. So when you're trying to release a new version of a particular of your API, uh, you initially want to route only a small amount of traffic to this new version so that you can test it and see if it actually works, test if there are any bugs. So initially, you can configure APISIX to route most of your traffic uh, to your version one or your existing version of the application, and route only some traffic to the new version of the application. And as time progresses, as you test your new API, you can then gradually increase this percentage and then gradually route all traffic to this new upstream. And it can also do stuff like fault handling. So circuit breaking is a good example. So if you have multiple versions, multiple instances of the same upstream, and you are load balancing traffic between all three, APISIX can detect if an upstream is not functioning. So based on status codes or some other metric, and then disconnect it from your system. So this will make it much easier for fault handling, because an issue with one instance of the upstream can cascade into the other upstreams and can cause a lot of bottlenecks in your backends. So uh, if you keep sending requests to the failed upstream, these requests will fail, and this will cascade into other services, and it can cause your entire backend to fail. So APISIX can handle those kind of issues by using this circuit breaker. And then redirects. So this is a very trivial example of how API gateways can be used, because fundamentally it just sits between your applications and your clients. So for example, like if you are deprecating an old API endpoint, and if you are moving to a new API endpoint, you want your client applications to make that transition smoothly. And APIFix can help you do that by like configuring redirects. So uh, even when the user uses the old API endpoint, API6 can send in a deprecation notice and then redirect it to redirect it to the new API endpoint at the backend, so that the user is abstracted out from all of your backend changes. And you can also choose to set a message and a status code, a 3xx status code, saying that you are being that the client application or the client is being redirected. So yeah, and this is a pretty neat way to use API6. And finally, monitoring. So monitoring is like very crucial when you're talking about reliability of your services. uh, when you want to identify issues before they occur, or like just to get some telemetry from your applications. And API6 being the central point where all your traffic comes can be a good place to collect these metrics. So when it comes to traces, API6 will be the initial point that generates the trace ID of single request, and as it goes through your backend. And it also integrates with other tools like Apache Skywalking, Prometheus, uh, and a lot of other stuff. It also has its own inbuilt metrics and logging tools. So so yeah, integrating with all these tools and providing some tools out of the box lets you configure traces, loggers, and metrics in API6. All right. So when API6 comes to Kubernetes, it does two things. So API6 is basically an API gateway, and in Kubernetes, it also comes with an API6 ingress controller. So API6 ingress controller is a wrapper around API6 to make it Kubernetes native. So so yeah, it is also hosted by the ASF. It is also completely free and open source. Uh, yeah. So what API6 does is it takes in the Kubernetes Ingress API, which is a Kubernetes native resource for configuring ingress controllers. So when an API gateway comes to Kubernetes, you can think of it as an ingress controller. And to configure this ingress controller, you need to define your configuration using the Kubernetes Ingress API. So the Ingress API enables traffic routing, and it's a standard API. So even if you switch API6 with some other Ingress controller, like let's say Nginx, you can use the same Ingress API to configure it, but it has some caveats which we'll look into later. And there are 20 plus implementations of the Kubernetes Ingress API, and Apache APISIX is one of them. So this will be more clear when we'll start looking at the demos. So let's see. All right. So we have a really simple demo. So we have Apache APISIX deployed on Kubernetes. We have two instances of Nginx servers, which basically so the left server basically responds back left, and the right server basically responds back right. So this will mimic two backend services in our cluster, and we'll send request to this uh, to this cluster uh, to the APISX gateway which is deployed inside the cluster, and see how we can route these requests. So our test use case is when we send a request to the left path, uh, yeah, we want the request to be routed to the left service. And when we send a request to the right path, we want it to be routed to the right service. All right, let's see. Okay, so this is the ingress configuration. So this is how you configure Apache APISIX with the Kubernetes ingress resource. So it comes out of the box with Kubernetes, and its name is Ingress, and its configuration is pretty human readable as well. So for our use case, we want a request to the path left or having the prefix left to be routed to the service left, and we want request with path right or prefix right to be routed to the request to be routed to the service name right. And we have already deployed two services named left and right, which are basically just Nginx, bare Nginx with some configuration that just returns left if it's on the left container, if it's on the left service, and right if it's on the right service. So yeah, so let's try and apply this manifest file. So to have this configuration, to deploy this configuration in Kubernetes, we just have to do the kubectl apply dash f. All right. So this creates a configuration in Kubernetes. And since we have API6 deployed in Kubernetes, API6 takes in this configuration, or the API6 ingress controller takes in this configuration and converts it to API6 configuration. So now API6 should have this configuration. So API6 should be able to route the request as we configure. So let's just try it. Mm, see. So yeah, so now we get a response back from the right uh, right service. Now let's see if we add another path. So it says right, and the path we sent was right API. Now, if we change this to left, it should route it to the left service, which it does, because now we are getting back the response from the left service. Yeah, sorry. So let's look at a bit more complex example. What we looked at was just basic routing. So when we move on to a bit more complex example, like when the user sends this request left app, we just want API6 to send request with this path to left. So strip out the left path, but use the left path to route the request. But when you send the request back to the upstream service, just strip it off that particular path. So this is a bit more complex use case for an API gateway. And in order to make that work with the Ingress API, you need annotations. So this is a drawback of the Ingress API. So just when you start moving to more complex stuff with it, you have to rely on annotations. And these annotations are specific to API6, as you can see. And this the Ingress API was supposed to be platform independent, or like vendor independent, but these annotations are still vendor dependent and very much dependent on API6. So yeah, but still, let's see how we can do this. So we have an annotation called rewrite target regex. So we will match this particular regex, and we will rewrite it with just the second part, or the suffix of left or right, and the rest of the configuration is basically the same. When it is left, route it to the left service. When it is right, route it to the right service. It's the same as before. So let's first delete the previous configuration and then apply this. So now if we send a request to left/API, it routes it to the left service, but uh, now the path is just API. It just stripped it off its path. So like I mentioned, as soon as you start doing complex stuff with the Ingress API, it requires custom annotations. Oh, I missed talking about CRDs. So let's just look at that as well. So annotations can get cumbersome, because like for each and every new feature you want to add, you have to add a particular annotation, and this makes it much difficult to maintain these, and makes it much difficult to like modify it, because you have to keep track of all your annotations, and then uh, figure out what an issue is, what should be changed, and all sort of stuff. So API gateways and API and ingress controllers, what they decided to do was to create their own uh, custom resources. So Kubernetes allows you to define CRDs, and that's exactly what we did. So APISIX comes with this with its own CRDs, which is called APISIX route. So it lets you define these configuration in a much more native way. So instead of relying on annotations, you can use these CRDs to configure APISIX, but it looks similar. So if it matches uh, a path, let's see, uh, if it matches any path, which this is basically regex, and if it has a query string with the name side, which is equal to left, route it to the left service. And then if it has a query string with the name right, then route it to the right service. So it lets you do more complex stuff, which is capable, uh, uh, which API6 has the capability to do, but it does it in a much more native way instead of relying on annotations. So let's see. Um, First, let's remove this, and then so we just created a route with this particular CRD. Now let's see the code for it. Yeah. Okay. Yeah. So now you are sending a request with to the API endpoint with a query string side is equal to right. So it should to the route to the right service, and it also adds this rewritten string which we mentioned in the configuration. So it lets you do more complex stuff which is capable by API6, but it does it in a much more native way. All right. So this makes Ingress a lot limited because as soon as you want to do more complex stuff, you rely on annotations or you end up using CRDs, which is not at all portable because uh, in using annotations makes it somewhat portable because the rest of the configuration remains the same regardless of the choice of ingress controller you are using, but CRDs make it completely non-portable. And there is also not a standard way to extend the ingress specification, the ingress API. So that's when the Kubernetes team decided to create the Gateway API project. So Gateway API can be thought of as a next step to the Ingress API to make it more expressive. So it should be able to do a lot more stuff that is capable, that API gateways are capable of, and it should have a standard way to extend stuff, and it should also be role oriented, which means uh, uh, like it should separate out concerns. So the application developers should only be concerned about creating routes, and the cluster operator and the infrastructure provider uh, can abstract out all the infrastructure and the cluster configuration away from the application developer. And the application developer should can only have access to create routes, which is basically what they want to do actually. And this makes it a bit more role oriented. Uh, you can look into it later, or we can discuss more about it later. But right now, let's look into a demo on how you can actually use the Gateway API. So nothing's changed here. Instead of the Ingress API or the CRDs, we are using the Gateway API to configure stuff. So let's see. Okay. So the Gateway API is still not available out of the box in Kubernetes. So it's part of this uh, alpha release, and most of its implementations are still in alpha beta stages. And as we are an application developer, and we are concerned about creating routes, so we create an HTTP route, and we do the same configuration as we did before. So we want to match query parameters, and if there is a query string that says side is left, then route it to left. And if a query string contains side is right, then route it to right. So this is a bit more complex use case, but the Gateway API supports this out of the box. This means that like you can use any implementation of the Gateway API, let it be API 6, let it be Nginx, or any other implementation, and this configuration will work for all of these without any changes. So let's try applying it. All right. Now, if we yeah, now if we send a request to it, it should work. So we basically did the same configuration as we did before, but now we are doing it with the gateway API. Now let's try and do a bit more complex configuration. Uh, so let's see. So let's see a bit more complex configuration, which is basically filters. So like we did before, we want to rewrite the URL. So we will rewrite it with this string, which has rewritten, and this is done through the filters configuration within the gateway API. So the rest of the stuff remains the same. If there is a query parameter with side that says left, route it to left, and right, just route it to right. So let's try applying this. And we get an error. It says there is an error validating this specification, and the filter rule is unknown. So basically, this configuration is wrong. But in reality, this is supported by the gateway API, but it is still experimental, and this doesn't work out of the box unless you install an experimental version of the gateway API. So I did this to show that like it still doesn't work because it's still in its early stages of development, and a lot of its implementation are still in alpha and beta stages. So it's at least for now, it makes a lot of sense to keep using the Ingress API or use the custom CRDs. But as the gateway API project evolves, I think it will replace both, and it will make it much easier to configure Ingress in Kubernetes. All right, that's all I had for you today, and I open the floor for questions. Feel free to ask any questions you have about APISX project, or uh, like traffic management within Kubernetes or anything, and I'll be happy to answer you.
I was curious, I saw it does gRPC transcoding.
Yeah.
Which is not something you would expect to see in a lot of places that are based on like Nginx. What is actually doing the transcoding?
Yeah, so API 6 supports gRPC transcoding. So basically, uh, both ways. Maybe I can show you the plugin. So API 6 is basically pluggable in nature. So you can extend API 6 through a lot of plugins, and yeah. So basically, the API 6 reverse proxy or the API 6 API gateway does the transcoding. So basically, it converts the HTTP request to gRPC request. Uh, yeah, you can check out this. Like if you are concerned more about the actual implementation, the code is completely open source, and you can check that out. But otherwise, like this document basically walks you through how.
Is that like, so is that like a C binary that is hot loaded as a plugin, or like I see that you can do Lua scripts. Like if you were using Nginx with Lua, pre-flight stuff, this can kind of do that natively. But like transcoding is a bit more involved than just that. Is it a separate C binary that it's kind of hot loading, or what's the the actual mechanism that it's using.
Yeah, I'm not sure if it's. I don't think it's a C binary because it's basically Lua code. So APISX is built on top of OpenResty, which is basically Nginx plus Lua. So extending Nginx through Lua. So most of the stuff that is most of the plugins in APISX are written completely in Lua, which does the. Uh, so basically, it would be Lua code that does this. I can probably check it maybe. Let's see. But I have to check the actual implementation, because I'm not familiar with it. But like API6 is primarily based in Lua, and most all of its plugins are written in Lua. Yeah.
Gotcha. Okay.
But you can also like write plugins in other languages. So API6 has plugin runners, which communicate with API6 over gRPC, and then you can write plugins in Java, Go, Python, etc., and basically run it outside API6 and let API6 communicate with it. And also API6 supports WASM plugins, so you can uh, compile your code into a WASM binary and run it within a WASM VM within API6. So it also lets you do that. But plugin wise, have to maybe check. Maybe. So,
Oh, wow. So it is just a bunch of Lua.
yeah.
I think it's all just Lua. You have to upload the protobuf for
Yeah.
your proto files too.
But like transcoding gRPC in Lua, I would have expected it to take more than that, but I guess it doesn't. I guess you could.
I need a lib, dude.
Just fucking go. Here you go. Like.
But it does both the question.
What's wrong with you?
You're not talking about how fast it is. They're just saying
Yeah, on,
do it.
on performance, what is the performance compared to some of the other API gateways? Because Lua traditionally is okay.
It's Lua JIT, so
Oh,
it
it's Lua
turns into
JIT?
Theacode eventually.
Legit.
OpenResty is Lua JIT. It'll be
Yeah,
faster.
yeah.
And so-
It uses the LuaJIT compiler. So, and we have run a lot of performance benchmarks, and
Also, do you
yeah.
have the kind of the overall architecture of all the components of API6?
Yeah. So if you go to the API6 docs, yeah,
When I looked at it, I was trying to figure out
yeah.
why on certain of them, but
So I saw etcd was being used, so that's where config and consensus and stuff is handled. The control plane itself, there was a repo that was a control plane written in Go. Is that something separate than API 6 default control plane? Is that like a custom implementation of it, or?
Yep. So traditionally API6 uses etcd, but you can switch it with other databases or rely on a completely static configuration. So we found like most of production users prefer static configurations over etcd because they don't want to manage an etcd cluster and like do all the stuff. But API6 can also be deployed in a standalone mode where the configuration is pulled from a basic YAML file, a static YAML file. And for the Go control plane, I think you are referring to the Ingress controller project. So let's see.
We had just an actual control plane too. I saw the controller, but then there
Yeah.
was.
This one?
Yeah, so that's
Probably.
Is the control plane written in Go, or it's like if you're using it outside of Kubernetes, which is just like managing, I'm assuming the Ingress controller is just writing those static configs to whatever the pods are. Is
It looks
that?
like it's making API. I might guess the API calls because all their examples show you posting configuration to it.
Well, one of the project was comparing itself to Pilot. So like, is there a Pilot type component, if you're not using Istio Ingress or not using the Gateway API, is there something that is managing all the endpoints and what's that written in or what?
Yeah, it's written in Lua. So the entire APISIX is in its entirety is written in Lua. So the control plane is yeah. So you can see this here. Wait, let me. So the data plane is an Nginx proxy with the control plane is basically the Lua stuff, the OpenResty stuff that is on top of the data plane. And depending on, so if you are on Kubernetes, we have the APISIX ingress controls is a wrapper around all of these stuff. So instead of uh, us directly providing the configuration to an APISIX specific configuration, the ingress controller takes in a Kubernetes native configuration and converts it to an APISIX specific configuration. So it's a wrapper for the ingress controller is a wrapper for all of these, and within APISIX itself, everything is written in Lua, and this is the basic architecture of all of it.
And so even the things like ClickHouse and all the other data stores that you might use to access or store metrics or anything, they're just like Lua scripts in the.
Yeah. Basically, they're just Lua plugins that you can like switch on and off when you're running APISIX.
So let me make sure I understand. So I'm assuming it's the community version of Nginx. So therefore, the hot reload of the config is using that Lua.
It's OpenResty, so it's the forked version, the community version
Correct.
that everyone else built on. So it does have hot reloading.
Yes. Yes, using that mechanism. And you're using etcd to facilitate a clustering of these API gateways?
So etcd is just a config database, one of the options for a config.
Right, but I mean, I'm trying to understand the nuance of when I would use it and when I would not.
If you're running like a fleet of edge servers,
That's what I'm asking.
etcd might be an easier way to store, or you compile everything down to static and push it out. So it's always one of those two. Do you want to have a centralized, you can view the world,
Yeah.
you know, with.
Because I was worried, I remember trying to do this a while back, in a poor person's way of doing it. And the thing was, is that it's an eventual consistency of a config, right, across the clustering of these API gateways. And so I was just wondering, is it better this way? Is it just different? Or is it still have those issues of, you're gonna have a route that potentially it was an older route, and now you're gonna have a bunch of new ones, and you're gonna have a moment of inconsistency. Is that, I mean, how do you resolve that if any way? Does that make sense to you?
Yeah. So for like if you are using etcd, I think it handles it. etcd handles these inconsistencies automatically because it's built to be distributed. It's built to be
Yeah, no,
it's built to be robust.
I
So
understand etcd pretty well, but the
Yeah.
point is that if you have a pretty significant configuration change, and you
okay,
have a cluster of these API 6
Okay.
ingresses out there, right? And that rolling of all that data, whether, it just seems like I'm trying.
There's a moment of inconsistency in
There is a
everything you
moment,
do all the
there's
time.
problems.
So there's two
Now it's
modes.
fine.
This is an OpenResty thing, not even an APISIX thing. The OpenResty will either pull for its config from a data plane on a regular interval, or you can push it to that. And if you know where all of them are, you can push to all of them at once.
And then poke, and then say,
And then they will all get that at the same
is
time.
so that's my question. Are you using etcd to actually? Yeah, how are you doing that consistency?
etcd is just the storage mechanism.
Right.
Yeah.
You could use Postgres, you could use flat files, you could do a dozen other things.
But is it also saying, are you storing back saying, yes, I've got your config, I'm ready to reload? Are you using it the opposite way? Is what I'm trying to understand.
So
I think it depends on the like.
You know what I'm trying to say, right?
maybe.
So I definitely SED has the configs,
Okay. You've updated etcd.
but you also want to make sure every one of them has it.
You want to make sure that every single one of the API
API,
6 instances
Yes,
has
has it.
pulled it from etcd or whatever
Correct.
your data plane is.
Yes. And then I can then issue,
Yeah, so either you have configured it to pull on whatever interval, or you have to go and tell each of them, go
Yeah.
pull.
and so how are you doing that telling of that?
Yeah. So if you have multiple instances, if you want to deploy APISIX in multiple instances, the way you can do it is by decoupling it from the control plane. So have one particular control plane and have multiple data planes. So each time you make a change to the configuration, it gets pushed to all of these data planes, and you have one control plane controlling all of these data planes. Does
And
that
then
make sense? Yeah.
sometimes then pass off the socket. So that's what they used to do when you couldn't do hot reloads. You'd actually have two side by side and pass the socket.
That's correct.
So that's the best way to do a full atomic if it
That's why I was wondering if they, yeah.
I can probably get back to you with a bit more nuance on how this is actually done. Maybe like
No, you're
week
fine. I
later.
just was trying to
Yeah.
understand.
Yeah.
So let's say Ambassador or Glue, or can't remember, is it Glue? I think it's called Glue or
Contour.
Contour or blah, blah, blah. What would be, a lot of them have a similar genre of features. What would you say then, would say, hey, this is why I would choose API 6 over one of those others? Because a lot of them have their own CRDs. They all have, the nuancing of canaries and blah, blah, blahs and all that. So what would you say would be the selling point of API 6?
A key factor would be performance and the whole community aspect of it and its extensibility features, because API6 is built with performance in mind, and a lot of optimizations it does underneath this to improve performance at a higher scale. And most of our users use API6 for particularly that particular use case, because they have 10,000s of routes. They are handling like millions of traffic requests every day, and you want something that is much more scalable. It should not break when the routes scale. So things like, let's say, matching routes, that should be optimized. It shouldn't be just iterating through an array of routes and seeing if it matches. So optimizations under the hood like that makes it really fast. And we done a lot of benchmarks with some of the industry leaders, let's say industry leaders in API gateways, and API6 consistently beats them in performance across multiple aspects. And the other thing is the pluggable aspect of API6. So you can basically extend API6 through Lua plugins. But even if you don't write Lua, or if Lua is not part of your tech stack, you can use Java, Go, or Python to write plugins for API6, and it works just as just as uh, just as good as you expect it to work, right? So, and the whole thing is community oriented. So and it's hosted by the ASF, so it makes it much easier to kind of trust it, because even if the company behind APISX goes out of business in the future, it will still be maintained by the community. So yeah. Uh,
So given that it's a lot of Java underneath, what's kind of the memory and view footprint for, let's say, the API gateway itself? Is it comparable to these others as far as
With Java.
Yeah, I say, where's the job come in?
OpenResty? Is that,
see.
oh, that's C?
Nginx and Lua specifically.
Okay, I was thinking of what was the Java one? What was that? Anyways, there's a project that did something like the OpenResty. I thought it was Java.
you mean the Spring Gateway or something like that?
Yeah, I saw something that was running on the gateway. that was using that as
If
well.
it's Spring, just ignore it. It's,
So this is
For other
pure, you're just using Lua as the plugin language, really.
And
Everything else
just the-
is native in this.
it's sort of like writing C in Lua because it JIT compiles it. So by the time you're actually running it,
It's fast.
it's as fast as if it was C. And should have the memory characteristics and, hopefully not the memory downfalls of like type safety, but it's.
well, it does.
It does.
It's Lua is often like, same with Nginx when you're doing Lua configs, you can like blow your whole foot off in one line if you're so inclined, but it opens it up to be able to do stuff. So like, I saw the match where if you want to write a custom match based off of something in a header protocol, whatever, they had mentioned, GraphQL, and GraphQL matching on methods is like, well, just get it into Lua, parse the stuff out and return, a false value, right?
All right.
This is an easy evaluation. I could sum it up in one
Yeah,
sentence.
you don't need to.
Don't
evaluate
use
this
Spring
one.
Cloud Gateway, then you're done.
Yeah, this was, we would never.
So like OpenResty, I think is what Cloudflare originally based their WAF on. Because it gives you the extensibility to write whatever kind of logic and rules you want, but the data plane is hardened, like it's
there.
well proven out.
This feels like a more sane version of Kong that isn't
Yes.
encumbered with all the crap.
Yes.
Does Kong use Resty as well, or is it?
Yeah.
That's
So
true.
yeah, we have. So we have this performance benchmark with APISIX and Kong. So you can check that out, and like we have a you can actually run these tests yourself. The repository is public, and then maybe you can test this on your own infrastructure, and then
Have you compared the Lua JIT methods of doing integration with WASM, and is Lua JIT going to remain the primary way of doing things, or is WASM getting to a point that you can more natively kind of compile things in and do the remote foreign function call stuff that kind of that's more or less what you're doing with Lua now, and getting additional languages in there? Do you think the WASM is going to take over, or is it still pretty far away out?
so right now, like I think WASM has a lot of limitations because let's say like if you want to write a Go plugin for APISIX and compile it to WASM, because it only supports the tiny Go compiler, the proxy WASM SDK. It only supports the tiny Go compiler, so you are limited to just use the features of the tiny Go compiler. And when you go back to Python, and if you want to compile it to WASM, you can't use a lot of Python modules. So the reason you might want to use Python might be because of its rich ecosystem. But if you can't use all of the ecosystem features, then it doesn't make sense to use Python, right? So WASM is still a long way, but we are pretty bullish about our configuration with like our implementations of WASM. So basically, we are trying to like let users bring in their own WASM VM. Like they can bring in their own WASM runner, and then basically uh, like basically make it as a plugin, so they can like give them full customizability over like how they use WASM with APISIX. But right now, I think the Lua plugins are much more capable than WASM plugins. But if it is some basic stuff, I think you can get away with WASM, and the performance is comparable. I would say for a very simple plugin, which basically like changes the response header. The performance is comparable. Yeah.
Yeah, Torbit tried that same thing and they didn't get those good numbers. They had to stick with Lua because they ended up, I think, the most popular plugins from tenants, they just baked into the binary as Go code. It was easier to do that than have an actual extensibility model.
The problem with WASM in this scenario is the edges, not the runtime that is being worked on, but like it's the same problem we've talked about before. And like network calling and stuff is not possible without like passing a whole bunch of crap around, and it's a logistical nightmare.
Here, they're not even having, so like a match function. Like some of that, you're not passing a ton around. And so like, if you didn't do it in a sandbox, if you toss the like safety of the sandbox, you might be able to get the interop out of the.
Yeah, you can get some of that, and like pure execution, once it's in there, like you could probably, but like as far as like inside the request cycle, like that's not feasible. You don't need to do a whole lot of crunching. So Lua as a glue is a better use case, even though LuaJIT is not maintained. And
Well, it is by, so they have a forked version of LuaJIT as well, just in
Yeah.
case they need to break from upstream. And I think it was the one started by OpenResty. So.
Any other questions? All right, well, thank you very much.
Thank you for having me. And like, you can find the code stuff. Yeah, I'll just share it on chat. Yeah.
We're good.
Awesome.
Thank you.
Thank you.
We'll get this video posted in a bit, but
Yeah,
thank you
sure,
all
sure.
that have attended. And again, have a good day for you, Navadu.
Yeah. Yeah. Have a good rest of the day for you as well. Yeah. Bye.
Cheers.